Hey friends, if you're using Playwright for end-to-end testing and synthetic monitoring, you might have discovered situations in which your application behaves differently depending on user settings, user location, or maybe even a certain time in the day. And I'm talking here about cookie banners or promotional banners that could show up at random. In this video, I want to show you how you can make your Playwright tests more flexible and cover these scenarios. Sounds good? Let's go. Let's look at this example application here running on my local host. It includes the headline Hello World and a sign-in button that, when I click it, disappears. But this application has something special. When I reload it, every now and then there will be a modal showing up that asks me if I want to receive a surprise. And when I then click Yes Please, there will be a raccoon image rendered right below our Hello World and sign-in button, but the sign-in button still disappears whenever I click it. So how could we write a Playwright test that covers both scenarios? Let's find out and get into some Playwright code. Here I have my editor and it shows a home.spec.ts file that includes a basic test that already navigates to this HTML file that I have running on localhost. Then it's locating this sign up button that is currently hidden because we already clicked it, and then it's clicking it, and then it's expecting that this button will be hidden. But the problem with this test case now is that this will be incredibly flaky because every now and then there will be a modal that stands in the way. And how could we find out if that's the case? Here's a Playwright pro tip. Whenever you want to find out if a test case is flaky, you can use the repeat each flag and run the same test cases over and over again and find out if they're passing constantly. So when I now run npx playwright test with the repeat each 6 flag, we are running this one single test case 6 times and we will get the results in a nice Playwright report in a minute. And here we have it. We see that 3 test cases passed and 3 actually failed. So let's have a detailed look. The HTML report is just a nicer way of the results that we just have seen. And here we have the 3 passing tests and here the 3 failures. When we inspect one of these failed test cases, we see here the Playwright action log, so we can debug what actually happened. But here's a Playwright pro tip. Whenever you want to fight flaky tests or debug what is actually going on, what you really want to do is you want to have a look at Playwright trace files. So let's find out what's behind these. Let's click trace file, and here we have the Playwright trace viewer. In the top area of the trace viewer, we will find screenshots of what happened on the page, and here we see it already. The modal that asked us for a surprise is standing in the way. And when we inspect what happened with our locator click call, we can go here into the action log and we see that Playwright is checking if this element is visible, enabled, and stable. It's scrolling, but then also it's telling us, hey, that there is a dialog element that is sitting on top of the button that we want to click. So how can we make our test close this modal if it is available and make this test case pass? Let's go back to our test case and first of all add another action. What we could do is we could locate this button that appears in the modal and we could simply click it. But this isn't solving our problem yet, because when we now run the test cases, we actually just inverted what we expect. So right now, the test cases will fail when there won't be a modal shown. So indeed, we again have a flaky test result. To get rid of the flakiness in this scenario, we have to have a look at how Playwright in JavaScript works. So Playwright test cases are usually defined in an async function, and even though this code looks very synchronous and sequential, there's a lot of asynchronous actions happening. So whenever you call click on a button, the wait here will wait for this function call, which is actually a promise to resolve or reject. And similarly, this assertion here, expect to be hidden, is also an asynchronous operation, and Playwright will wait for this promise to resolve or reject. And if we don't want that one of these promises is throwing up our test case, we can handle every promise individually. So we can go in here and we can add a catch handler that will catch this throwing promise on the way. So when we now run our test case again, we should have an entirely passing test suite because Playwright will attempt to click this button, and if it's not there, it will reject this promise, which we're handling right here in this catch statement. Usually you would handle the error if something throws in your JavaScript code, so there's also an error object. In our case, though, all we want to do is that this error is not throwing up our test case. And this works just fine. But I don't know about you, but I think this one line can be easily overlooked. How can we make this code more expressive and easier to read? And the answer to this is a good old try-catch statement in JavaScript. Let's remove the catch handler of this promise and include a new try-catch statement. We can now move this code into the block, and it's very visible that it could be that this part of the code could throw an exception. And then if there is one, I will also remove the error handling here because I don't care about the error. So what we now have is we have pretty much the same structure, but because we have this await call in this try-catch block, Playwright will try to click the button, and if it's not possible, it will catch the error that is included. So let's see if that works and run again our 6 test cases. And here we go again, we are all green. The beauty of this refactoring now is that we can place multiple instructions into the try block. So if we want to also check that the raccoon image is rendered after we click yes, we can easily do that too. Let's ensure that this actually works and include a console log here and say raccoon is visible. Run our one test case 6 times again, and let's see how often we hit this try block. 1, 2, and that seems to be it. But all our tests are passing, and we now included conditional logic to interact with elements that only show up sometimes. At the end of the day, Playwright written in JavaScript is just that, JavaScript. You can leverage try and catch, you can use async and await, and you can deal with all these promises however you want to. And this is the beauty of it. How do you handle these scenarios? If you have any comments or questions, drop them below. And always remember, if you use Playwright for end-to-end testing, you probably also want to use Playwright for end-to-end monitoring with Jack Lee. And with that, I will talk to you very, very soon again, showing you the next Playwright tip.